Hi guys, so in this video we would be solving a DSA problem which was recently asked in Google interview round. So the question is something like this. So we have an array as the input and our job is to find the maximum sum subarray with a constraint. And the constraint is the first element of the subarray should be equivalent to the last element of the subarray. So I hope you know the subarray. Subarray is nothing but the contiguous portion of the array, right? So this is a subarray, but this is not the valid subarray. Why? Because the first element is not equivalent to the last element. But this is a valid subarray because the first and the last element are equal. So I have to maximize, or I have to find the maximum sum among all the such subarrays, right? So our answer is 14 in this test case. Why? Because the sum of this particular subarray is maximum among all the subarrays. Also, this subarray is a valid subarray because first and the last element are equal, right? So let's talk about the constraint. The constraint, I mean the size of the array can at max go up till 10 to the power 5. So this is hint number one. Hint number one is I have to solve this question in either O of n or O of n log n, right? But we'll start with the brute force approach and try to optimize it. So let's check out the brute force approach. So we are dealing with the sub arrays, right? And we know that the sub array has the starting index and the ending index. Okay. So what I'm doing is I'm using I pointer as a starting index and using J pointer as the ending index. So if I is pointing over here and J is pointing over here, so this is the sub array we are talking about. Okay. And this sum will store the sum of all the elements in this sub array, right? And I will only note the sum of this sub array if this condition is satisfied. That is, the first element of the sub array should be equivalent to the last element of the sub array. Then only we are trying to maximize the sum. So this was a brute force approach. And the time complexity of this approach is of n square because of the nested for loops, right? But this this approach won't be accepted in the interview round because of the constraint as well. So what we'll try to do is we'll try to eliminate one of this for loop. Okay, there are two for loops, right? So let's eliminate one of this. What I'll do is I'll try to eliminate the first for loop, that is the outer for loop. Okay. If I am successful in eliminating the outer for loop, then the time complexity will become O of n. So let's do that. Okay. So one thing is we still have the inner for loop, right? So what we'll do is we'll iterate through this array using that j pointer like this. Okay. We'll iterate like this. So what j is saying? So first of all, let's assume j is over here. Okay. Let's assume j is over here. So j is representing the last element of the subarray. Okay, so this is what j is representing. So for a j, I need a starting index, right? For this ending index j, I need a starting index. And what else valid starting index are possible? According to the condition, according to this condition, according to this condition, for this ending index, the starting index can be this, this, or this, right? Why? Because if last element is 3, the first element should also be 3, right? And that's the reason why for a particular j, I want to know the valid starting index. So when I was solving this problem, what I thought was just maintain a hash map for the starting index like this. So this would be the hash map where this is the key and these are the indices for that key. So currently we are talking about this 3, right? So 3 is over here and the indices seen till now are 2, 5, 7. So these are the indices seen till now, 2, 5, 7. Okay. So when I was solving this, so at that time I created the hash map. But notice one thing, like if this is the ending index, there can be many starting index, right? So how to know which starting index we should pick? Okay, see, this is one starting point, this is second starting point, and this is third starting point. Now which one is the best among all this? This is the best among all this. Why? Because the sum of this subarray is 14. Okay, the sum of this subarray is nothing but 10. Okay, and sum of this subarray is nothing but 13. So you only tell me, like if I have 13, 14 and 10, which one you will pick? Obviously this one, right? Because I have to maximize the sum of a subarray, right? So if I want to pick this, I want to know all the sums, right? That is 13, 14, 10, and I will then pick the maximum among all this, right? So in order to pick 14, I should know all the different sums. But in order to know all the sums, again I have to iterate through all of these indices. That would cost O of n square overall. But without iterating, I want to know this in O of 1 time. Okay, how to do that? So let's see the next slide first. So we were talking about three different indices, I1, I2, I3. These are three different starting positions that are valid for one ending position, right? So what is the sum from I1 to J? What is the sum from I1 to J? So this is the total sum, right? This is the total sum. And from this total sum, if I eliminate this part, I will get the sum from I1 to J. And that is what I have written over here. So maximum sum 1 is nothing but the total sum minus prefix of 0 to I1. And if I want to find the sum from I2 to J, what I'll do? I'll do the same thing. That is total sum minus prefix of 0 to I2. And same thing I'll do with this I3 to J. Okay. So these are different maximum sums. I mean, these are different sums. Okay. Let me name them sums like this. This is sum 1, this is sum 2, this is sum 3. Now, I want to pick that sum which is maximum among all these sums, right? So this is what I discussed over here. One sum was 13, one was 14, one was 10. I picked 14, which was the maximum. So that is what we are doing over here. That is, there are three different sums and I want to pick the maximum sum. Now observe the RHS. RHS has this particular part common, right? So it means that this sum is dependent on this prefix, okay? And observe the sign as well. Sign is negative. It means that sum is inversely proportional to prefix in this problem, right? it means it also means that if this sum is maximum among all the sum, then this prefix would be minimum among all the prefix. I hope you are understanding this part. I repeat that I want to choose the maximum sum among all this sum, and I also know that it is inversely dependent on prefix. So if this prefix is the smallest prefix among all the prefixes, then obviously this sum will be the maximum sum among all the sums, right? So what I decided was, while solving this problem, was instead of having the indices, I will have the prefixes like this. So the prefix from 0 to 2 was -5. The prefix from 0 to 4 was -6, and prefix from 0 to 6 was -2, right? And now, since I want maximum sum, among all the sums, I will choose that prefix which is minimum. So I will choose the prefix which is minimum among all this prefix, right? Right. Now, how to choose the prefix which is minimum in O of 1 time or O of log n time? So we can do this using set data structure, like this would be stored in the sorted format. -6 will come first, -5, and then 2. -6 will come first, -5 will come later, and then 2. So the first element would be the minimum element, right? And now that I have found the minimum prefix, I know the maximum sum. So total sum from 0th index till this index is something like 8. Okay. And from that, I am reducing -6. So 8 minus of -6 is nothing but 14. So I am getting the 14. And this is our required answer, right? So this is how we are calculating, or this was the solution. But observe one thing. We are only concerned with the smallest prefix and not all the prefixes. So we don't even need the set data structure. What we can do is just note the minimum prefix seen till now. This will be clear in the code. Okay, so let's see the code only. Okay, so this is the code, and this is the array that we will be working on. And I have defined one function named maximum sum subarray with constraint, which takes array as the input. And I have also defined the hash map. This hash map will store the minimum prefix for a particular element. Okay, and total sum would store the total sum from 0th index to current index, and this is the maximum sum that we will be returning. So I am traversing the array using the j pointer. This j pointer represents the ending index of a subarray. Now for this j pointer, I need a corresponding I pointer. So that's the reason why we are using the prefix array, prefix hash map. So basically, the prefix till this j. Okay. So if this is the j, the prefix is nothing but this part, right? So I've noted that down over here. And this is the total sum including the current element. Now I am checking the hash map whether that element is present. That is, if the current element is 3, I want the same element to be the starting element, right? So if let's say 3 is not even present in the array, then I cannot have the starting element, right? So that is what I am checking. Like hash map should have the same element as a key, and if that same element is present, then in that case I'll choose total sum minus the minimum prefix seen for that element. That is total sum minus the minimum prefix, that is this. So it will become 8, which is the total sum, minus of minus 6, which is 14. And this 14 is nothing but this particular part. I hope you understood this thing. So once I have calculated the max sum, when I am going to the next index, I will be saving the result in this hash map. That is, if j is over here and j will go to the next index, right? So I will store the prefix from index 0 to index 8 into this particular value section of the hash map. I hope you understood this thing, right? And this was when the hash map had the same element as the starting position. But if there is no such same element for the starting position, in that case we'll just store the current prefix. Okay, and then finally we are returning the maximum sum over here. So let's run the code and check whether the output is 14 or not. And indeed it is 14. You can check out this code for different test cases as well, and if you have any doubt you can comment down. I'll answer all those comments. Okay, thank you.